Huh?
Said, I think activating the microwave wirelessly from your phone is getting a little extreme.
Extreme? I don't think so. I think the future is.
If you're in the kitchen, you're cooking it, Chad. Why are
Well,
you gonna be?
well, what if
Why are
you're?
you gonna be playing with your phone with all the food and the water and the shit and everything?
Yeah.
It makes no sense.
It's beautiful.
Running the thing unattended. It's like pumping gas.
It's dangerous. Okay, okay. I have never seen people who are anti their job. You guys should promote this. You're the designers. We want more automation.
Oh, that doesn't require wiring. That's the problem.
More automation.
Yeah,
Okay. Building. We talk. Automation, guys, becomes a big deal when we talk about building automation system. We will talk about building automation system in the coming quarter. This time is just residential, automating a house. A few things, houses for the future. And Chris, feel free, you and Nick, to agree or disagree with this, but you guys will do it for Chad anyway. A couple of technologies that you guys can use as of now, available technologies. I know, Chris, you told me about the X10 technology.
Yeah.
You can use X10 technology, a couple of other technologies that's there for you. This baby, the Zigbee and the Z-Wave. These are all technologies, wireless and wired, that you can use to remotely control power equipment, lighting, and low voltage system and sound and so forth. So what's the outcome, Tao, my friend? The outcome is to be able from your smartphone, hopefully at one time, and I think it's the technology is there, so you can turn, not the microwave because Nick doesn't like to cook his stuff, but for example, how about cranking up your heat, lowering the heat down, right? Or programming your heat. Well, right now the thermostat can do that. Programming your heat at different stages, or just before you go home, you send the signal to your thermostat to go up and warm the house to be cozy and warm. That's nice, right? How about if it's a sunny day or something, and you want to open the I don't know if you have the technology yet. Opening the windows and closing the windows and the shutters and all this good stuff. So the possibilities is endless, guys. Turning lights on and off. How about if you're in Florida and the technology is there right now, and you want to turn and you forgot to turn the light in your house off or something? You want to check if the light in your house is off. Or on, or you turn a certain light on and off so people know that you're there. So technology is you can argue with it, but I think it's a great idea. You can have wireless or you can have wired. We can talk about wireless and wired, my friend. A couple of terminology that we use in the industry, and the key word, guys, is automation industry. We go Egan companies. Nobody here works for Egan, right? And I don't know if you, Elliot, guys, if you do it, Elliot, they have a monitoring. They contract with them to monitor churches and schools and everything else. So they have a monitoring system that they control the light. They monitor their lights and heating system minimum, and security system is completely monitored 24/7. So in a commercial building, guys, it's a big deal. Big deal automation. In residential, it's coming. It's coming. So Cat rated cables. We'll talk about Cat 1 all the way to Cat 7. What's the difference between Cat 1 and Cat 7? Any question, guys? So these are what we're going to try to do. Talk about X10 technology. X10. Anybody have installed X10 other than Chris? Chris, you installed them, right? X10 technology, my friends, is supposed to get you very easy. You're supposed to have 3 pieces. One piece is going to be the sender. Other pieces could be the receivers, and in between a keypad that you program the system. You'll see. You'll look at it in a second here. So if you have, let me go directly into my okay, no, I don't want that one. Let me go directly into a couple of pictures about them. All right, come on, load. Okay, so I think the one that I would like to, here you go. If you guys look at this is called the 10x technology. 10x technology. You're going to have your general, remember the signal bridge that you talked about, Chris? Signal bridge. So if you're sending things on hot 1, it should be able to communicate with hot 2. So you have your signal bridge right in here. And then you have modules that senders. These are the senders. They send information X10 on hot 1 and X10 on hot 2, these guys will send a signal, guys, over the power. Over power. It's a high frequency, not high frequency, a frequency other than the 60 hertz frequency and the 50 hertz frequency that you can send over the power lines. This bridge will allow you, if you send a signal on hot 1 and your equipment is in hot 2, to bridge between hot 1 and hot 2. And all what you have to do now is you go very easy. Take this. Here's a circuit breaker, and here's a piece of equipment, and this is also a 10x receiver, or X10 receiver here. And I decided, Ashley, my friend, to plug in a light here. Plug in a light. This is your receptacle. So here you go. It's 20 amp going to feed your receptacle. It plugged into. It's a plug-in X10 receiver piece. You can program the X10 module, guys. You can program it to turn this light on and off at predetermined values, different times, and so forth. The way this system works, I don't know how many of you have done that. The way the system works, the X10 technology will send the signal. In this case, let's just go this one. It will send the signal, guys. What is the frequency that they use? They use the frequency 1200, 120 kilohertz. They send a signal of 120 kilohertz. Look at this one. They're sending a signal 120 kilohertz right over the power lines. Utilities use this, guys, all the time. Utilities use the power lines to transmit signals. And at one time, Zach, they were a talk, and I'm sure probably you involved, Chris, they were a talk of opening the interstate, the national grid for transmitting data, not just power, between the state, opening the grid, the national grid for transmitting data. The challenge with that one, utilities don't want, they are afraid of interference between their safety equipment and operation of the grid and your telecommunication signals. That's the only, the talk is still there about opening all these interstate highways, the grid, and you send the signal right onto the power lines. How do you send the signal on the power line? Power line conductors, guys, from a telecommunication point of view, and correct me here, Chris, if I say something wrong. From a telecommunication point of view, guys, conductors are like highways. I can put a car in the highway, that will be one signal, my voice, or I can put a truck in the highway, that will be the power signal to power the equipment, or I can put a motorcycle on the highway, that will be another signal. So right on the same cover, you can send multiple signals in telecommunication. Unlike power, guys, you send only one signal for the most part, one frequency signal, 160 hertz frequency signal, power circuit, power line. On the same signal, you can make other signals ride the same cable. So look at this. Here's this signal is coming in here all the way through the circuit breaker, all the way to the equipment. Now, when this, Nick, my friend, when this X10 receiver, it has a device that can take that 20K hertz and act upon it, make things happen. Basically, turn it on and off or dim it. Turn it on and off or dim it. But look, see how the communication happened? There's no wires right on the power lines. Right on the power lines. Does that make sense? That's a very powerful concept, right on the power lines. Does that make sense? What you do is you have a programmer, you program these X10 module to say at 10 o'clock I want this light to turn off. Okay. Then at 10 o'clock it will send the signal through the power line into that receiver that's plugged into the outlet, any outlet, or hardwired into the outlet, and it will turn that light on or dim it or do whatever you want to do. Or I hate to say the microwave turn on and off here, but
so that what the red wire, which you have the overcurrent protection.
Yep, it goes right through the overcurrent protection. So if you turn the overcurrent protection device, I don't think it jumps over it. It goes right through the circuit breaker into the equipment. I'm not showing the neutral. The neutral will be here. This is your equipment here coming the neutral, right? So it's really unique, as in the signal goes right through the power line into the device. Right in the device, it digests it, separated from the power, and but you have to have a device to receive though. If you don't have a device to receive it, so you have the sender, the receiver, and if you made a mistake, I think you said that one, Chris, yesterday. If your equipment is on this phase, they have a bridge here that somehow direct the traffic between the two HOTS. If your equipment is plugged in hot 1 and your receiver is in hot 2, the bridge, signal bridge, is supposed to direct the signal to the equipment regardless of which line is the equipment connected to. Which line. So I can have this piece of equipment connected here, I assume, and I program it from this extend module here. Because it goes through that bridge, the bridge understands what's going on and
Just repeats it. What it
Repeat-
hears on-
repeats.
If it hears on line 1, it puts on line 2 and vice versa. If
It
hears something
takes it,
on line
repeats
2,
it?
puts on line 1.
okay. So it repeats it, direct it
Without
repeats.
shorting anything.
Okay, and that's where basically the signal bridge, you have to have a 15 amp. I want to remind you guys, 15 amp. I've never installed them. Anybody installed them? Chris, you installed them, guys, or you just programmer?
Both, but I
Both?
mainly on the program.
Programmer side. So I want to remind you there is a 15 amp 2-pole coming to that circuit, to that device, electronic device that could be sitting right next to the panel. Any question, guys, about this technology? What can you do with this technology? You can turn light on and off, heat, cool, stereo goes on off, you name it. Your security system, adjust certain things in your security system. So the possibility is not endless, but you can do, based on what they're saying, you can do 256 address. You can pick 256 address to do things with it. That's based on the smarter than Chad Curdy in the telecommunication. That's a lot of information for a house. You can pull a lot of data and do a lot of things with 256 address. Any question, guys? Now, feel free to agree or disagree what it does, but it's a good programming device. The disadvantage, what's the disadvantage of this one? They're saying, Chris, there's a couple of disadvantages. Remember that signal here? Ashley, do you see the signal that's coming out of here? It can go out this way and to your neighbor. It can go out, right? Because you and your neighbor are tied to the same transmission line, distribution line, and transformer, right? So it could go interfere with the operation of your neighbors if he has the same technology. So the smarter than Chad, what they do is they block it. They have some type of blocking that prevent it from going to your neighbor. Now remember, you and your neighbor and I and everybody in Texas and all over the US are tied by a wire, right? Does it ever strike you guys that every single house in America tied to and business tied to every single house in America by a wire, right? The national grid is interconnected. So technically we're all connected. Wire-wise, wired. We're all wired together. Wired, literally, by power. So instead of this going all the way back and screwing up your neighbor's equipment, they block it. So that's number one.
So if we want to see the world, we should become electronic.
So they have filters. What's the disadvantage too? There's a lot of this noise. The disadvantage number one is, guys, it goes screw up your neighbor's stuff, interfere. The second one is it's noise. It carries noise. Because these cables are non-shielded cables and the signal is affected by noise. Noise is third radio frequency signals that you can receive on the antennas or the power lines. Long story short, it could malfunction because of interference with noise, other signals picked up by the power line. Noise, other signals, stray signals, nasty signals picked up by the power line that could affect them. And the second one is it goes to all your neighbors, which you can block it through a filter. Any question about this technology? How do you use this technology? You have to put these bridges here. These are the senders. This bridge to bridge between the two HOTS, and also receivers. At the other end, you have to plug in a receiver in the power line. The receiver right down to the receptacle. So you put all this, you put it right in the panel or around the panel, and you have the receiver right here, and there's no wire in between them other than the power lines. As long as they're tied to the power line, you're good to go. And it's not wireless. This is not wireless technology. Any question, guys, about this technology? Any question about this technology? Chris, you still matter? You're not married. Here's a. Let me just go back. Okay, here's the receiver. How the receivers could look like, guys, plugged in. This is hardwired receptacle. Hardwired receptacle. You plug it in. It has sensor to receive the signal on the power line and separate it. A couple of other modules that you can use. On the receiving end, I think we don't have anything. Okay, no, we don't want that one. Don't want that one. Here you go. Programmer. whatever you do, you need to be able to program it. So this is your tool for programming. I don't know if they hardwire it or you plug it in, or you have to have some type of plugged in.
Self-contained unit just plugs in and then inputs the signal on the wire.
So this one will plug into the
You can buy an
unit.
adapter for a computer that you hook to this. The old style computers have these serial ports on them. You
Plug it
send
into
from
the unit.
Serial port to this adapter that then plugs in, so you can send signals. You can tell this adapter to send the signal via. The computer tells this box to send the signal.
Okay.
The receiver gets it. One of the major problems with that older stuff is what's called ears only. It would hear, but it would not reply. So if you say turn off, it doesn't tell you.
Confirm.
There's no
Doesn't
acknowledgement.
confirm.
So you can get out of sync, and a lot of them were simple toggles. If it heard a signal, it changed position. Well, if you don't know where you were to begin with, you don't know whether it's on or off. It creates total havoc, and that's what we found over a few months.
Okay, so that's not the best more adaptable, but the cheapest though, it's a cheaper equipment. So so that's basically your technology. I'm going to go back into my PowerPoint presentation, buddies, and so we talked about the technology. The technology has been there since the 70s, so it's not new, especially if Chris worked on that. Technology and the lowest technology in cost. You have signal superimposed. Here's the term, guys. Superimposed. I like always to draw a line like this for those of us who want to go to the next level. Here's your power circuit here. This is your 60 hertz, and then when they say superimposed, and I'm going to try to, so they can have all these signals. So that would be, what was it, 120 kilohertz. 120 kilohertz in that, and I'm just trying to summarize here, 120 kilohertz signal riding on the same bus. Any question, guys, about superimposing a signal over another signal on the same line? This is a major telecommunication concept, not a whole lot in the power. Okay, control components plug into an existing receptacle. You can plug them into an existing receptacle, or you can wire the receptacle itself as a receiver. Send a signal, receive it, program. Send, receive, program. Any question about this extend technology? Any questions? Anybody want to go install one in their house? Here's a programmer, laptop keypad controller. Pre-programmed signal to receive the modules. Here's your modules that we talked about. Any question about 10x? X10, I mean.
I used one in my real house. This thing I worked on was a research project. You're funding it out. I have a simple switch that goes to exterior lighting. So you buy this thing, it's about $15. You get a little switch in a box, and you can put it in the house. You put it anywhere, you can stick it out at the same point. Down with a low voltage transformer is you plug that in and plug the low voltage transformer, and you flip the switch and pop the transformers on. But if you happen to flip it and you're out of range, you think it's in one position.
It could be in
So
different
the
position.
switch becomes go on off. Basically, change whatever you're doing, change it.
Okay. Any question, guys? X10. I think they're available commercially. It should be commercially available. You can buy them if you want to.
I got this from Radio Shack.
Did you? Wasn't cheap.
You still have to go look and see if it did what you told it.
It did what it told. Okay, that's a drawback. Okay, moving on to the Zigbee technology. This is wireless technology, my friend, and I don't know how many have installed it. I've never installed it. Wireless technology system that use low power radio signals, wireless. You can use it at your house as a wireless personal area network to turn things on and off. A couple of things you need a coordinator, a router, and end devices. So multiple devices are plugged in different areas and they talk to each other wirelessly. The frequency that they use, where's the frequency?
2.4.
How much?
2.4 gigs.
Thank you. They use a frequency 2.4 gigahertz. That's a lot of frequency. Hi. Guys, when it comes to telecommunication and control, frequency is a big deal. Unlike power, where we have we have three. Anybody can know what the power frequency we use? 60 hertz, 50 hertz. The third one,
400.
400. Is it 300? I thought 300.
Military.
Yeah, 300. 300 hertz. 300 hertz. These are the three commonly used frequencies that we use. Is it 400?
That's what
Maybe.
it tells us, and Derek was saying the military stuff.
Well, I could be wrong. 300, 400. Can you check it, Steve? Chris? Anyway, so the most common ones obviously is the 50 and the 60. In the telecommunication industry, the limit is the sky. The limit is sky in terms of telecommunication. Okay, so you can plug these in. Another technology that they use, guys, is Z-Wave, low power wireless communication system. This one area plug-in, a couple of things. What's the frequency on this one? The frequency is this. Well, this is high frequency. Instead of giga, not a whole lot. It's point. Let me put it in a giga. 0.87. This would be a 0.87 gigahertz. It's in the mega range. This is in the mega range, or 870 some mega. Work fine with range up to 100 feet. Plug-in type, not compatible with X10. All the goal is, guys, to control certain equipment or certain loads in your house. Any question about another technology? Z-Wave, anybody have seen it, done it? No? Cool. Move on to the second one. How do you say that one? Insteon? I don't know if I'm saying it even right. This is another technology, guys, that you can use wireless or hardwire. What's the advantage of this one, Nick? Is it works with X10. So if you have an X10, that would be an extension and compatible two systems together. You can do a few things in all of them, guys, not just in this one. You can turn things on and off, security sensors, turn them on and off, receiving them, alarm, heating and cooling system, humidity, door locking. You can lock your door, unlock, control of appliances, as well as audio and video control. Now, we take this. Locking, unlocking door, that would be a good advantage, right? You lost your key or something or whatever. You can, from somewhere remotely, you can turn, lock and unlock your house. I don't know how important that one for a lot of us, but Chris, Nick, my friend, you agree with me, for a commercial industrial building, that's a big deal, right? Being able to open, lock and unlock things. We use them a lot in the fire alarm system. Fire alarm system, guys, doors, certain doors have to be interfaced with the fire alarm system. And upon existence of fire, you need to be able to unlatch that door so people can get out of there, they can't burn. But you keep them locked because to prevent the thieves and the thugs and the hyenas from stealing things from the stores, right?
Well,
So these are...
Some of those thieves, thugs, and hyenas are fairly smart too. And
You can hack it? Okay, well, then there will be a smart ones too.
I don't think, Chad, in the long run, I don't think we're gonna see any difference in theft and security. For a hard key door
Versus electronic door? Okay.
If somebody really wants to get in any place, I don't care where it is. I don't care if it's a casino. They'll get in.
Okay.
If they do their research and they work hard.
We'll just keep honest.
Let me tell you, okay, that's the security. Let me tell you about the humidity and the cooling. This is very interesting. You know how many people in Minnesota have cabins? I mean, I'm not going to tell you. This is everybody has cabin. There is a technology right now that can get, if you have a cabin up north and you want to make sure that your heating did not break or something, you can send, with this technology similar to this, it can send you on your iPhone, tells you the cooling, the temperature have dropped below acceptable level in your cabin. Now that's important. You're not going to disagree with me. Why? Or your house have been broken, or your cabin have been broken into, or the more better than that, it's the temperature has went down because everything is going to freeze if you're not winterizing your equipment. That technology, I know a colleague of mine here at Dunwood is using it as we talk. His cabin in Wisconsin sent him a signal on his phone that his cabin in multiple times have been broken into, or have the temperature have went down. So he knows he have to drive all the way 2 hours to his cabin and solve the problem. That's the power of this type of technologies. And that's not a new. Yeah, and that's not a, yeah, absolutely. But that's the power of this type of technologies. I mean, for these, the peace of mind. You know, you guys have seen all the commercial where that ladies goofing around with the people turning on the iPhone, closing the door. With that, I'm a you know, how much you're going to use it and what you utilize it for. I think it's great. I think it's a lot of future for it. Now, security is one part of it, but there's a lot of convenience stuff that can come out of it.
I know, I'm not saying it's totally bad.
Okay, moving into, so these are the wires, moving into a completely wired house, guys, with LAN system, local area network. So during the rough end, you pull your cat, and not a whole lot of people are using cat because of the wireless right now, but you could wire all your house with cat 5. I did that with my old house 10 years ago, wired it with cat 5. If I can capture cat 5 from every location in the house, all the bedrooms, I can bring them to a central area. Now I have my local area network. I can network printers, it's like an office. So that's a very powerful concept. So you can have a combination outlet, central distribution system. I think they have a structured wiring completely with cat 5 and so forth for security. Here's how it looks like. And I'm going to go pick to Rob, my friend. They're calling it service center. Right into a box like this, you can network a lot of locations in your room. And Phil, my friend, I want you guys to wait until we talk about controlling light, and you hear from the guys who do control lights, and the possibility is endless for controlling commercial or industrial or residential light, and even security and heating and cooling system. You can have a center like here. You wire it, you interface it with your phone or wireless, and you can get tons of information about your equipment. You can have your cable TV, you can have your phone, you can have your network completely coming out of this system, telecommunication, audio, video, home automation, all of them right into this system. And I believe they're selling a lot of systems like this, guys. So you can automate your house wireless or wired. You can do a lot of stuff, turn your TV on, off, receive signals, monitor your house, turn lights on and off, you name it. Cook your meal if you're not Nick. A couple of recommendations, guys, for this communication cables. There's a couple of UL standards. Just FYI, for all these optical fiber optics come with all these UL standards. Have to be listed. So you have to be very careful. The audio video guys, the low voltage guys, you have to use special attention when you terminate these equipments. There's low voltage guys. Noise is a big deal on these low voltage equipment and distortion. So special attention have to be given to the selection of cables when you deal with this equipment. Cable that can get you audio, video, and data. You can have multiple, you'll see a picture of it, guys. You can have one cable that has multiple conductors, coaxial cable, cat 5 all-in-one jacketed cable, so they can do a lot of stuff with them. And the combination is endless. Manufacturer, of course, catalogs to find. You can go and check manufacturers. Okay, a couple of terminologies with this, guys. I thought if you are to go into this, there's a few terminologies dear to the people's heart who work on it, guys. Radio grade equipments, RJ6, that's the jack. Notoriously famous RJ675, that's a jack that we use. F connectors that comes with the coaxial cable. M is mega telecommunication, and giga, and this is my favorite, is byte per second, bits per second, or bits per second. What's the bits per second right now they're giving? What is it? 20 mega. I think the wireless that they have, they're giving 10 to 20 megabyte per second. Are they selling more than that? That's what I hear from my carrier, right? Phil, anybody can help me who has a internet? Isn't that 20? No, internet. Internet.
Well, Comcast will advertise first rates of up to 100.
100?
Bits. There's a big difference between a byte and a bit.
Mega, yeah, the bits.
True measure of bits, and then what you do with them.
I think they do mega.
Bits.
Bits is the 8.
How many ones and zeros?
Yes.
Per second?
8 bits can make a byte, right? It's a word. What they call it, the word. Okay, so this is the speed. The key important, this is your speed. This is how the speed of your equipment that you want it to work. How important is speed for you? Megahertz, the bit, we talk about the bit. That's the binary, with 0 or 1. The byte is 8 bits equal a byte. These are good good knowledge to know. And megabyte per second, megabit per second, MB. That's how they measure the speed. Do they measure in byte or bit? I thought bit, byte.
What's truly
MB.
significant is bits.
Yeah, so when they say 20, they mean 20 megabit per second, 20 megabit per second.
What's getting convoluted is byte was based on this eight bits representing something, and it's changing now. Because the original
16.
computers were 4-bit computers, and eight became huge for a long time. Now we're looking at these are 64-bit computers, 128.
And keep,
it's been out
yeah.
for a long time, hasn't been implemented.
So all
The
these
key is just how many bits, because what you do with it after that
is up to you. How many bits? Okay. Okay, so wireless, structure wired involves separate conductors if you're using wire, 10 technology, remote control, infrared. Some of these guys need an infrared technology that need line of sight for these devices to work. Infrared can be bounced off shiny places, and how automation system vary. Choose the one that fits you. And the other thing I want to see if we missed some of the pictures. So really, this is a good introduction that could ease you into automation, building automation system. Couple of categories, guys, couple of jacks that you probably have seen them when you install them. I'm going to go all the way to Cat 5s. Here's the multi cable. You've seen a picture of that probably. Different type of cables. The last thing I want to talk about, guys, is 5E and Cat 5 and Cat 5E. And I'm not an expert in telecommunication, but I believe the most important thing, one of the most important things is the speed, 350 megahertz, the speed that you can connect these data, or the signal that you can send across these data, Look at this one, 7 is 750 megahertz, and so forth. So Cat 5, Cat 5e, and Cat 6 are the most common with telecommunication. Any question, guys, about this? Any question? Got that one. So to summarize, my friend, it's if you would go that route, it doesn't make a whole lot of sense for a lot of us guys building out a house automation system. It's a big deal when it comes to the building automation system. The whole industry is built on being able to automate everything inside your building, monitor the lighting, mainly the light and the heat, and security of a building. That's a major part, guys. Being able to monitor the building heat and cool system, that's a major part, as well as the lighting system, because we're becoming green society more, and of course the security of the building. Okay. Ashley, any question, my friend? Any question about that one? So that will be a quick one for you. All right. Very interesting and very important, because it will prep you guys to sizing generators for emergency system, as well as standby by system. The NDC code, guys, have three systems, very important, three very important systems. System number one, Zach, my friend, is called the emergency system. These systems have to come up within 10 seconds. Major part of it is the egress signs and the exit signs and egress light. So that's within 10 seconds, emergency system. The code talks about this, we'll talk about this one, guys, later, which is this Article 700 in the NDC code book. There's another Article 701. This is emergency system. This is legally required system. We're not going to talk about these two. And the last one, guys, is 702 is standby. That's my standby. So there's three systems in NEC code book that you can back up your building with. Actually, my friend, the emergency system by code have to come up within 10 seconds. Legally required standby system has to come up with, anybody knows? What's the time that the equipment have to come up with for legally required standby system? 60 seconds. And all these information are from Article 701, guys. And how about the standby system? How long do you want it to get up? Whenever, I always say here, whenever Chad finishes his cup of coffee and go turn the switch on. Okay, 3 very important systems, 700, 701, 702. I'm not going to talk about 7, I'm not going to talk about emergency, I'm not going to talk about legally required system, guys. Now, this is coming in next quarter. We're going to talk today about that system 702, which is whenever, the standby system, because we're talking residential. Any question about this, Ashley, my friend? Rob, any question about these 3 systems? Emergency, legally required, standby system. We're talking here about the standby system only. So whenever, not required by any government, and just FYI for us only. Okay, so everybody knows that 3 articles that talks about it. We're talking about right in here. This is the one that we're talking about in this example, 702. The whenever. 700, 701, 702, 10 seconds, 60 seconds, whenever, emergency system, legally required, standby. Emergency, most of it, likely people's life depend on it. Legally required, the government, be it state government, federal, or county government, or city government decided that certain loads are very important for the public safety or for whatever, and that becomes a legally required standby system. And it has to come up within 60 seconds. Any question, guys, about this? We'll talk about the other 2 systems later, but the most important one today is the standby power system. Okay, standby power system. A couple of safety issues, guys, when it comes to standby power system. About a power system, guys, I hope you understand what we're talking about is we have a grid and a service coming to my building, and I need another source of power to tie to the grid, either live or synchronous or non-synchronous, but another source of power to my building. That's what we're talking about. Standby power, a couple of basic things about standby power. We'll talk about this one. And standby types of standby power system that you can do. The major type we're going to talk about, guys, is a motor here. Diagram for portable standby generators. So we're going to have a portable generator. You're going to see a nice picture about it. And transfer switch, you can transfer from one to another. And means to disconnect the power, as well as size the equipment, big deal. And of course, the Bible, always have to be consulted about everything that we do, right? The NEC code book have to be consulted about everything that you do. All right, the picture is really easier said than done. I'm going to go all the way to my picture, guys. There you go. Here's a very interesting standby power system, and I want you guys to look at this one. This is very important when you design a standby power system for a house, residential only. You can use it for commercial, but this is commonly residential. I want to bring to your attention that this generator is portable generator. One way of having a standby system, guys, is to having a generator. I can have a solar system standby. I can have a wind system standby, right? I can have any source of power standby. The most common source of power standby is generator, by diesel engine generator or gas generator. I want to bring to your attention this way. You can do it 2 ways, actually multiple ways. 2 are common. One is a portable generator. You can grab that one, put it in your driveway. If it's a portable generator like this, it comes with a cord, and you plug that cord into an outlet, as you can see right here. And that outlet will feed a critical panel that could be in your garage. The critical panel right in here could be in your garage. This panel will feed certain loads from in here. You are feeding, one major load is furnace. Another load right here that I could be feeding from is my fridge. I don't want my food to go down. A couple of other loads that I can feed here is certain lights. What else can I do from there? Here's another load that I can do here. Fridge, furnace, what else? Sump pump, if you have a sump pump. Sump pump, I want my sump pump to be backed up. So look how this system works. You go to your house, here's your service. You come to your service, right? Inside your service, guys, you have your panels. And I'm not going to tell you what you have here. Nick, you have the grounding, the neutral bus, and the main ground bus here. You bond them together. Can you guys see the bonding here? This is typical. Can you see the bond between the neutral and the ground? And then you pull a grounding electrode conductor, and we all know how to do that. We all know how to pull a grounding electrode conductor, right in here. That's inside your service. Up to this point, every one of us have this panel in our homes, right? The second thing you add is you add close to 40 or 60 amps, commonly 40 or 60 amps. Here's a 40 amp. You bring a feeder, 40 amp, number 8 conductor, all the way to another sub panel that could be in the garage or a basement, completely sub panel. Inside the sub panel, it comes designed with this 2 circuit breakers. These are the single most important thing, guys, right in here. The single most important thing about the whole system. Safety. If you have a generator, they want you to have 2 circuit breakers that mechanically interlock. This is how they work, mechanically interlock. If you turn the generator circuit breaker on, it's connected, the utility with the same movement will be off. If you turn the utility on, the circuit breaker for the generator will be off. Anybody knows why? The worst thing that could happen to you is you turn your generator and connect it to the grid without syncing it. Because the generator frequency, guys, and voltage will be at this level. And before you tie them together, we're going to talk about Verling next quarter, but before you tie them together, you have to start syncing until the 2 voltages and frequency line up like this. Then you throw the switch. Otherwise, it's equivalent, I have been told by the people who did it, is equivalent like driving in down 35W at, say, 75 miles an hour. There's no police there. And putting your gear in reverse. I don't know if you can even do it with the new cars. Grabbing your gear and moving it into reverse. What's going to happen to your car? The sounds, the damage they're going to do to your car. Anybody ever done that one? I don't know if in your new car you can even do that. Can you allow you to go reverse? And probably there's a lot of interlock that you can't do that. Or lower if you have a gear car, lower it to gear 1. If you're going at gear 5 or 4, and you move it all the way to gear 1 while you're going 35 miles an hour. You can see how many metal is going to damage. Long story short, if you tie to the grid without being in sync, it will burn your equipment. Period. Okay, so that's number 1. Number 2, the other number, guys, so you're guaranteed you're not tying with the grid when it's running, number 1. Number 2, if the grid is off, you also don't want to feed power back into the grid and kill the lineman who's working right up on the transmission line, right up somewhere in here. Right? Because you can feed back into the system. So that's why we have this very important 2 circuit breakers, 2 pole each, mechanically interlock. Any question about this? 2 mechanical interlock. Okay. So I have my 40 amp. I have my 40 amp over here too. And then all these could be 20 amps each. And feeding different loads. So here's what happened, guys. Normally, you're running with 40 amps and all your equipment are running from the grid. Can you guys see the red line coming and feeding this sub panel? Under normal condition, you're running with the grid. Up normal condition, if something happened and you lost the grid, we have snowstorms here, and we lost the grid. What happened is you go physically, mechanically, walk in when you finish your breakfast, lunch, whatever you're doing. You go there. You grab this is unplugged, so you go to your garage, pull that portable generator, move it all the way closer to the power outlet, which is usually outdoor, right? You plug it in and push the button here so you can start your generator. How long will it take you to do that? Somebody like Chad, probably 2 minutes. Oladipo, half an hour. Oops, did you say that? Okay, so there's no limitation on time. My point is, can you do this in 10 seconds? Can anybody pull that one in 10 seconds, plug it in and energize? You can't, unless you're a Superman or woman. So this is not an emergency system. Okay, I want to bring to, yes?
We have some generators that are designed to start themselves automatically.
We'll talk about, give me 1 second. This is manually starting here, most of the time. I want to bring to your attention, guys, that there's a cord with it, there's a plug with it that you have to do. And and you have to push the button. This voltage on this could be 240/120 in this case, or any other voltages. And we have all your equipment. Chris, one thing you don't do here is you don't bond the neutral and the ground at the second panel. This is called separately derived system. Where do we have that one? It's called separately derived system, right in here.
Does that mechanism isolate the neutral as well as the hot conductors up on the lower left?
This is a separately derived system. This here is separately derived system. Does this mechanism isolate the neutral as well as, if it's a separately derived system, it should be. So 3-pole, you have to have a 3-pole breakers. If it's separately derived system, you need to be able to
It says it switches.
switch to neutral. You have to be able to switch it for separately derived system. Separately derived system, you have to be able to switch the neutral. We consider separately derived system, so you have to be able to switch your neutral. Okay, so you have to be able to switch a 3-pole breaker right here. You bring your neutral, so you can switch your neutral as well. Switch your neutral as well. Okay, so separately derived system, you turn your generator on, you have power. Any questions about this? Separately derived system. A difference between separately derived system, guys, and non-separately derived system. As you bond the separately derived system, you're going to bond the neutral to the ground. Separately derived system, but non-separately derived system, you do not bond the neutral to the ground. Okay, so this one, portable generator. One of them, okay, separate 3-pole, double throw transfer switch is permitted. And okay, small of we consider separately derived system. Okay, so this system is considered separately derived system. Separately derived system. And what they do, guys, for this one, they bond the neutral and the ground right in here. I'm going to draw this. They take the neutral and the ground, bond them right in here. I don't know if you guys can see that. And then they bring the hot, the neutral, and the ground, and it's bonded right inside the frame of a generator. That's why it's separately derived system. In the portable generators, they're considered separately derived system. So you have to switch the neutral through these 3-pole circuit breakers that they switch the 2 hots and the neutral, and they're bonded right in here, the neutral, so you don't have to bond again. Chris, if you can look here, I'm not bonding in the panel because it's bonded right through the transformer. What's a separate? We'll talk more, guys, about separately derived system, but separately derived system is when you bond the neutral and the ground at the generator here. If you don't bond them, it becomes non-separately derived system. Any question about this? Any question about this? So we're running 3-pole 480 switches, neutral. And if you look at this here, I don't know if you can read this, very important, guys. That's you switching the neutral. The reason why we switch the neutral, everybody knows why we switch the neutral, because it's a separately derived system, is you switch the neutral as well as the hot. You do not want to depend the neutral of the utility. That's what a separately derived system is. It has its own neutral. You run at your own neutral. Actually, I want to bring to your attention that then, where's the grounding electrode conductor for this generator? Always, where's the grounding electrode conductor? If it's separately derived system, I have to go ground a rod and tie it. But this is portable. If it's portable, they allow you guys to bond the neutral, because that neutral here has to be bonded. Look how they bond it. I want you guys to follow with this inside this cable. Can you guys follow that one inside this cable? This cable is going to be have a grounding conductor that's eventually tied to the grounding here and going all the way back to this ground. Can you guys see that the frame of the generator is grounded through the grounding bar in the critical panel, which is in return grounded through the main panel through either the conduit or an equipment grounding conductor. And that's okay for portable generators. If it's fixed in place, we do it slightly different. Fixed in place. Any questions, guys, about this? This is it. This is how you tie a standby generator system. Standby generator system. How many circuit breakers you're going to have? You're going to have 10 circuit breakers or 6, mainly 6 or 12 circuit breakers. You don't bond the neutral here. So if you're doing this in your house, you're not going to go bond the neutral on the ground right in here. This is, if you can see, this is completely separated, the neutral and the ground. Why? Because we're bonding it right at the generator, This rule, if you guys read through this junk here, it's okay for you have to do it for 15 kW or less. 15 kW portable or less portable generators, that's how we do them. Portable, they have to be portable too. You see the word portable? We're moving it. Do I have to drive a ground line from here to the ground? No. Any question, guys, about this? Any question? So that's how you do it for residential. Look at the next. This is the same picture that you guys are looking at. Now, if I lose the power, so power is gone from here, look what happened. The first thing you need to do is you need to go to that little switch here and flip the switch, right? So now the switch was on the utility. I lost utility. I'm going to go physically, mechanically, and turn this three-pole switch, three-pole right here. If you look at, here's a three-pole and three-pole tied together. One of them is up. I'm going to go switch that one to the generator is up now. I'm tying this panel to the generator and isolating it at the same time from the main panel. That's the most important thing. Tying to the generator and isolating from the main panel. Okay, then you go there after you finish your cigarette if you smoke, and your coffee if you drink coffee like Chad. You go push the button and start that generator. How long will it take you to do that? 10 seconds? No, probably a couple of minutes, 5 minutes, 10 minutes maybe. Is there any limitation on how long will it take you for a standby system? No. Had this been an emergency system for a hospital, you can't do this. This is mostly residential, or even you can use it for commercial that doesn't need an emergency system or legally required standby system. Any question, guys? Any question about that? Any question? That's the cheapest, easiest way of doing power in a house. The easiest, cheapest way of doing power in a house. And I can't emphasize, guys, the importance of the information for three-pole 440 amp breaker that switches the neutral, and another one that switches the neutral here. As you wire them, you want to isolate yourself from the utility. Any question about this? That's the cheapest they can get. Let's go to the next step up. Step up. That would be probably you're looking at, I don't know, 3 kW to 5 kW arrangement generator, 3, 1.5, 1.5 kW generators tied this way. If you move into the second, let me see if I have, okay, I don't have the other one. Let me look at the other arrangement if you want to spice it up a little bit. Let's go to, look at the pictures because it's more important than the lingos. Let's go to the next step up for generators. Okay. As long as we're here, guys, also they have, this is the cheapest. Actually, this is cheaper even than the one that we did. We have a portable generator. This is usually in construction sites where you have a portable generator. You have receptacles on them, and you can plug into the generator. That's mostly for, you don't even have a plug to plug in. You have like equipment come with a plug, and you plug the equipment directly or indirectly into the generator. That's for construction sites. Here's what we did for a house, portable generator, right? We're running, can you guys see that we're running right now on generator? We're running on the grid here. We lost the grid, we run on generator, as you can see. Moving on to the next step. Here you go. This is the next step up. This is the next step up. If you look at this one, if you guys look at this one, this is permanently installed generator outdoor. Permanently installed generator outdoor. Permanently installed generator outdoor. You have a transfer switch. Let's look at, this is your main panel, the same arrangement. I have 60 amp, came through a conduit, EMT, and I fit an auto transfer switch, auto or manual, could be auto or manual. And then from there, I went and I fit a sub panel. In this case, this is a 60 amp sub panel. A 60 amp sub panel. And from one side, from the other side, I fit a generator. Now this actually can be a separated drive system, or it could be a non-separated drive system. Your choice. The way we're showing it right now, the way they're tying it, you're gonna, if you switch the neutral it depends. How can you make a separately derived system or non-separately derived system? Are you going to switch the neutral? So if I'm going to switch the neutral, then this auto transfer switch, or it's going to have 3 poles, right? It's going to switch the hot, it's going to switch the other hot, and a neutral. If you switch the neutral, it becomes non-separately derived system. If you don't switch the neutral, it becomes a separately derived system. If you switch the neutral, non-separately derived system. If you don't switch the neutral, it becomes a non-separately derived system. A non-separately derived system. Okay, let's follow this one, guys. Equipment neutral bus isolated from the metal enclosure. I want to bring to your attention, guys, look at the neutral and the ground here are isolated in this case. Now, if I want to run this one, let's run this one as, if this is a three-pole circuit breaker, a 3-pole auto transfer switch, so I'm switching the 2 hots and a neutral, this becomes a separately derived system. Here's how we do a separately derived system. If you look at the inside the generator, you have the hots. So here's my hot coming in here. Here's my other hot coming in here. Let's go to the neutral. Right in here, oops. Let's use a green. Right inside the transformer guy, the generator, I'm going to the ground, and I bring my neutral directly into, directly in here, right? And I switch my neutral. So here's my neutral. I grounded the neutral right at the generator, and I went into a grounding electrode conductor that I'm driving right next to the generator, or I'm tying with the existing grounding electrode rod in the area. I don't know if you guys can see that. In this case, this will be a 3-pole circuit breaker separately derived system. You have a ground rod, and by the way, Ashley, as you know, you have to take this and tie it directly to this too. So you have grounding electrode conductor here, and a grounding electrode system here, grounding electrode system. These two have to be tied together. They have to be tied together. The neutral is grounded at the generator. I'm switching the neutral through the auto transfer switch, double pole, double throw switch that switch the 2 hots and the neutral. So my neutral from the grid and my neutral from the generator are not directly tied together. They are eventually through this wire, right? But they're not directly tied together. That's a separately derived system. That's your separately derived system. Do I have to do it this way? Can I run with a non-separately derived system? Yes. What's the difference? What's the difference, guys, if that was a non-separately derived system? What's the difference? The difference is right in here. The difference is right in here. Can you guys see that little wire here? You still need to see that bonding. If I want to make it non-separately derived system, by code I have to drive a ground rod if it's outdoor. Now my ground rod go and bond the frame. Look what I did. I took the ground rod, tie it to the frame. I still have to do that. If the generator is outdoor, tie the frame of a generator to the ground rod. I still have to tie the 2 ground rods together, here and here, if they're not the same ground rod. If in a lot of applications, guys, in residential, your generator is going to be right next to the ground rod anyway in the backyard, and you tie directly to the same ground rod. So this ground rod here and this ground rod here could be the same ground rod. And who cares? As long as they are the closest to the generator. Okay, so if I do this, then look what happened. Then I need to change this one into a 2-pole circuit breaker, and I'll take my neutral. I'm going to follow my neutral right in here, and my neutral right, where's my neutral bus? Right in here, and my neutral, see, I'm not switching it, and my neutral follow all the way, where's my neutral bus? And right in here. If I do it this way and I don't switch the neutral, these are all neutral. If I do it this way and don't switch the neutral, this is called a non-separately derived system. If I switch the neutral, then it becomes a separately derived system. A separately derived system. Any question, guys, about this? Which one should I do it? Either way. What's the advantage of doing it this way? Cheaper equipment. Instead of a 3-pole circuit breaker, you're using a 2-pole circuit. Instead of a 3-pole transfer switch, you're using a 2-pole transfer switch. Cheaper equipment. Any question? Any question? I want to bring to your attention, Rob, my friend, you need, look at this. What is this? Disconnect. If you have a permanently installed generator, you need a disconnect within sight of the building. So you have to put a disconnect right next to if it's outdoor, within sight of the building, right? Do I need a disconnect inside the building? No, you don't. As you enter the building, this transfer switch could be in your basement. You do not need a disconnect for it. You just directly to the switch. You don't need a disconnect to this panel, obviously. The only disconnect that can disconnect this panel directly is this switch here, this one, or this one. Okay, now, if you have a transfer, can you guys see the transfer switch? It takes an act of God and somebody who determined to kill himself to connect the generator to the grid at the same time. It will, because the auto transfer switch, guys, is double pole, double throw. If it goes to the utility side, it will at the same time, it's connected to the utility. When you move it to the generator, it switch first from the utility and go down to the generator on every pole and the neutral if it's separately derived system. So why don't I have to have a tie between the circuit breakers? Because the transfer switch will act as a separation between the grid, the utility, and my separately derived system or non-separately derived system, the generator. Tell my friend any question. If you guys understand this, when we move into generators next quarter, which we're going to be sizing for the two projects that's coming, it will be very easy for you to understand. Can I run this as a separately derived system? Yes, bring it on. Can I run it as a non-separately derived system? Yes. What's the difference? Are you going to bond the neutral at the generator or not? That's the difference. And if you bond the neutral at the generator, then you have to have a separately derived three-pole switch here. You know, because you're going to switch the neutral. If you don't, then you have to have a two-pole switch here, and then look what happens if I don't. The question would be, Ashley, is, Chad, if you didn't ground the neutral here, where would the neutral be grounded, right? The neutral have to be grounded. Look at that. I didn't ground the neutral here, so keep moving. And you can see that right in here. Keep moving, moving all the way through. Where do you think the neutral got grounded? Right in here. Right in the panel. Right in the panel. If you do it this way, there's two signs you have to put. Two signs by code you have to put. Sign number one, guys, by code, you have to put a sign right in here on the service. This is a sign. The sign right in here should say, Nick, right at the service should say, a second feeder feed this building. So the firefighters, when they walk into the service here, they should be able to see a sign of a disconnect location outdoor. So you put a sign over here, right next to this disconnect, and a sign. So each disconnect is going to have a source of power. You're going to have a sign that says another feeder feed this building here, and also a location of this feeder, and also here another sign that says another feeder feed this building. So a firefighter walks in and they want to fight the fire, and they turn here's my disconnect. Look what happened. I disconnect this. If this is an auto transfer switch, it will start the generator. If it's an auto transfer switch, it will start the generator. So when I walk in to fight the fire, I can see a sign, oh, another source of power is here. So, and the location is in the backyard. So I go in the backyard and also disconnect the two sources of power. That's safety. That's sign number one. Sign number two that you guys have to have right next to here. This is brand new in 2011. This is sign. Look at this. Phil, my friend, what happened if I tamper with the grounding electrode conductor while the generator is running? What happened if I tamper with the grounding electrode conductor if it's a non-separately derived system? If it's a non-separately derived system, what happened if I go unplug this bonding jumper, this one here, or the grounding electrode conductor, tamper with it, meaning disconnect it because I want to service it? Thinking, well, this panel is dead. I de-energize it from here, not knowing that this system is still running on the generator. Well, who cares? I'm not into this system. I'm here, Chad. But your neutral here is grounded right at the panel. So in 2011, the smarter Chad discovered that somebody could be zapped really good if anybody's to tamper with the grounding electrode conductor. Not tamper, just maintaining. If you will maintain it, disconnect it, work on it. While this is dead, So I disconnect it, start working here. I want to disconnect this conductor here because I want to change it, do something. If you disconnect this conductor, it could be zapped because a neutral current need to go back, could be grounded right through the system, number one. And also you can float the neutral. Now you have a neutral floating here. Your equipment here might not get the 120 that it's supposed to get. We ground because we will reference to the ground. Now you go disconnect this. If you have a ground fault here, it wouldn't be even seen. So anyway, so you have to have a sign in 2011 that says don't tamper with the ground electrical conductor because another power system is using it. Any question, guys? And second thing I want to bring to your attention is this conduit. Can you guys see this conduit? This is for control signals. So if you have your generator outside fill, I have to have a power conduit coming to the disconnect right next to another PVC conduit carrying the control wires. Control wires for the most part, guys, is only if you have an auto transfer switch. This one is auto transfer switch. Look at this. I have my auto transfer switch here and my generator. An auto transfer switch actually, can you see all these control wires here? It senses, it's looking, there's sensors looking at the power coming from the utility. The minute it senses that there's no power right in here, it sends the signal through these wires directly to the generator to start. If it's an auto transfer switch, if it's manual, doesn't do nothing. There's no control. If it's an auto, it sends a signal to the generator. Hopefully the generator is warm enough and there's a battery inside the generator. Crank that generator and start. So if you're at home, there's a storm, knock down the distribution line to your neighborhood, your auto transfer switch is sensing, it sends a signal to the generator because it has a generator has a battery backup in it, little battery for control. It starts the generator through this battery, and it switch this one back to the generator, and your house, your critical loads is up and running. Your critical loads are up and running. Now what happened when the power comes back? When the power comes back, it senses that there is power back, it waits for 50 minutes. We have a delay on them. It waits 50 minutes. Let's make sure that it's coming back for good, right? Because sometimes it comes back, goes back again. Since 50 minutes, the power is stable. It switch you back to the utility, and it waits for they call it idling. It waits for 5 more minutes. After 5 more minutes, the generator will run 5 more minutes to idle, to cool down, and then it turns the generator off. All this is happening through the control system between the auto transfer switch and the generator. And we will talk more about this one, guys, as we move into the commercial industrial building. That's how we do it, an auto transfer switch. If this is an emergency load in a hospital or anywhere in the building, this must be an auto transfer switch. No option. Manual transfer switches is not an option for a legally required system or an emergency system. Not an option. A standby system like this, it's an option. Any question, guys, about this? I can't emphasize, you guys, when you study it, look how we separated the neutral. No more bonding. We do not bond here. Why? Because we're already bonded here if it's an unseparated drive system. And if it's a separated drive system, Chad, we already bonded right in here, right at the generator if it's separated drive system. Any question? Any question? So you can get up to 7.5 this way or even higher. kW, I hate to put any value on that one. Generator for homes. I mean, you can get as high as you want to go get, but you can put 500 kCA, 500 kW here this way. You can go as high as you want. For the most part, you don't go higher than 500 kW for a lot of applications. If you go 2 meg and 3 meg, you start doing it slightly different. We call it paralleling. Any question, guys, about this? Very important to see the separation between the control and the power circuits. If you guys want to understand what we're going to be doing next quarter and the quarter after, these 2 paragraphs must know. These 2 pictures must know. Okay. Here's what happens, guys, when I lose power. When I lose power, I transfer myself to the generator. So when I lose power, single phase, okay, the bonding jumper at the generator must be removed if a two-pole transfer switch is used, a two-pole. This is what we said. This is, guys, just to give you an idea that if you're running a separate drive system or non-separate drive system. Any question? Any question? Running on generators? Okay, the last thing I wanted to talk about, guys, how do we size generators? How do we size generators? Well, there are two ways of sizing generators. One way is do it by hand, which we would never do. The second way, next time with your friend Chad, you're going to do two softwares. One coming from common software that we have. Common software, guys, you take all the loads that you need to back up. In our case, it's going to be all the loads in the building. Plug them into a software, and the software will do two calculations. Will calculate based on two things. So that's why I want you guys to pay attention to this. It will look at the operating, the running current, and the starting current. So this is I run, and this is or the watt. So really, it looks at the volt amp run, and this is volt amp start. And everybody knows what the volt amp run, guys. So you add all the volt amp of all the equipments that you want to run. That's easy, Chad. I have a blender. I'm giving it this amount. I have a broiler. I have it this amount, and I have a central air conditioning. And I bought this central air conditioning, so I'm going to add this amount for it, 6K. And you keep going. Compute. These are all suggested values. All suggested values. So in my building, if I have gas and added this, these are all suggested dishwasher or this. I'm just picking the stuff that I'm having, guys, in my building. I have a water heater, and I'm picking this amount for it. And I have whatever. I have a clothes dryer, and I'm picking for the clothes dryer. Electric, I'm picking, well, you already picked gas, so you can't pick that one. So you pick, these are all, the ones that I highlighted are the loads that I'm going to be feeding from the generator. So what do you do with them? Add them up. And then go and you came up with 400. If you add, when you add them up, say you're going to go buy a generator that can give you this kW or higher. That's it. Take the second one. That's for the run. For the start, the same thing. You're going to go to the start. Next, look at the blender. It takes 600 watts to run it. But when I start it 14 seconds, how many watts do I need just 14 seconds? 700. The inrush equipment has an inrush, guys. When you have a generator, the generator has to be powerful enough to push things to start. And when things are up and running, it has to be powerful enough to continue running it. The start is just to be able to start the equipment. It takes more power to start the equipment than to run it because of the inrush. Take this. I have a broiler. It takes 16. There's nothing on that one. Look, this is substantial. For the PTU, guys, for 1400 PTU air conditioning, for an air conditioning, it will take 6 kVA to run it, but it will take 18 kVA to start the compressor. 3 times more, and that's coming for motors. 3 to 6 times more is coming for motors. Anyway, I'm not going to convince you guys that you need to add all these. Now, the question always comes to me, and they say, Chad, how the heck am I going to get these? By the way, if you have a water heater, look at the water heater, it's 8.8, because water heater is no coils in it. It's a heating element. The inrush becomes substantial if the equipment has a motor in it. If the equipment has a motor, the inrush is substantial. Okay, look at all these. Then you add them up. Then let's just suppose that we came up with 40.4 kW here. And let's just suppose that's what we came up here. And I know it doesn't add up to this. And let's suppose that we came up with 14 kVA. And I came up with 14 kVA right here. So Nick, you're going to go to Cummins and tell them, oh, by the way, I need a generator that can run 4.4 kW and start 14K. You have to give him the two values. Otherwise, you can't size a generator. You have to size a generator based on two things. Please remember this for the software that is coming next quarter. Help me or help you. Because the software that we have, Ashley, is going to ask you when you plug these numbers about two numbers for every load. It will tell you, okay, what's the horsepower of this equipment? Here's horsepower, 515 horsepower. What's the starting of this equipment? If you don't know, it allows you to pick the the code letter for the equipment, and based on the code letter from the NDC code book, it will assign a starting KVA for it. So the software is really easy because it walks you through the start KVA. Okay, add them up. In a case like this, here's what I'm going to go by. I'm going to go by 5 kVA generator, and the starting capability, this is a run. And the starting capability is 15 kVA. Done. What's the voltage? You need the voltage and frequency, depending on what your voltage and frequency. We size generator based on two things, running and starting current. Questions? Any questions, guys? This is very, very substantial when you work with generators, to be able to, if you guys go call any generator guy to size generator, they ask you what's your load and what's the largest motor. They ask about motors that you have, so we can be able to start that thing. The worst thing that could happen, guys, you have a huge motor that you can't even start that baby. If somebody's to start it, it will run, but you can't start it. So Nick, here's what you become very smart next quarter with Chad. You have no control over this because the owner is so stubborn and he wants to run these, right? No control over this, right? You cannot control that one. That's the owner. You have a full control over this though, or the start current. How can I control the start current, guys? You can reduce this number by doing very simple thing, starting things in sequence. Instead of starting everything at the same time, so add them all up like we did, because they're all going to start at the same time. What if I make a control system that will start them in sequence? The largest load first, wait 10 seconds until it's stable, the second load, the third load, the fourth load. If you do it this way, you will reduce the starting capability of the motor. Who cares? The question is, who cares, Chad? Cheaper, smaller size motor, cheaper equipment. So I want you guys to highlight this one. And remember, next quarter when we size the generator, you have full control over the starting current by starting them in sequence, not at the same time. Make sense? So that's your capability. So this is a good guide, Ashley, for residential, obviously. If you will size a generator, you pick the loads that you have here, add them up, and that will give you the size of your generator. Any question, guys, about sizing generators? Any question? Let me go back to my PowerPoint and see if there's anything. Standby system, basic. Okay. A lot of safety issues, guys. Wrapping up. Obviously, when you deal with generators, extremely important. The worst thing that could happen is, Chris goes without discussion, running your generator in the basement. Right? You're burning gas, natural gas or whatever inside your basement, uncontrolled natural gas, not vented outside. So make sure when you burn your generators, guys, when you run them outdoors. So there's a few things about and gasoline properly storage. You have to store your gasoline properly. A few safety things that you have to do to turn off power when hooking up generators. Goes without discussion. Run your generator outdoor unless you want to vent them. Highly unlikely you're going to have a generator running indoor because you have to have a venting issues, a lot of vent. You're burning gasoline or natural gas, and that's dangerous if it's not vented outside. I'm not going to tell you something that you don't know. Work electrical equipment when do not stand in water and work electrical equipment. Read the manufacturer instructions. Okay, generator do need simple, complex, and we talked about this one. We talked about the simple part that you can do, guys. A couple of generators. Most of the generators that you buy, or a lot of them, are gasoline-driven generators, motor generators, what they call them. You can run them. Here's the amount, and here's how much you can buy them. I think Home Depot sold them up to 5 kW, if I remember right, for residential. These are residential. You can commercial. The sky's the limit. Most of them is, guys, commercial. We run diesel, a lot of diesel. If you get into the commercial and diesel, you get problem. I'm not going to open the can of worms with EPA regulations. So for residential, not a whole lot of regulations, but if you go commercial, you have a lot of regulations when you have a standby diesel generators. Okay, we talked about this one. Manual starter generator, flip transfer or plug-in. We talked you can start a generator, guys, by the plug, the easiest, cheapest way. Then you can go on manual transfer switch as we wired it, or you can have a transfer switch that's non-manual. It's going to be an auto transfer switch where you can be anywhere and your generator can start. Your generator can start. Okay, transfer switches. We talked about separated drive system, and we will continue talking about separated drive system as we go, guys, in the commercial industrial. We'll continue to talk about this one. They don't want you to kill the lineman work. That's why you have to have the isolation auto transfer switch, manual transfer switch, or interlock circuit breakers. Interlock circuit breakers to isolate yourself from the grid. So because you don't want to hurt yourself or hurt somebody else, have rating 40 to auto transfer switches, guys. For residential, here's the sizes that you can buy them. Chris, for commercial, the sky's the limit. You can go as high as 4,000 amp, which we will talk about this one as we go. Non-separated, this is interesting. Please, if you want to highlight this one for me, non-separated drive system and separated drive system. Non-separated drive system, properly grounded through the grounding electrode conductor system of the premises wiring. This is the key point. The neutral is grounded through the service. Separately derived system, the neutral is disconnected by the transfer switch and grounded right at the generator. These two terms, if you guys know them, it will help you a lot as a designer, a lot. Which system should I use? Can I use? You can use any one of them, as long as you remember. If you're running non-separated drive system, the neutral cannot be switched. If you're running a separated drive system, you have to switch your neutral. If you're plugged in, you have to run separated drive system. You have to switch your neutral, the portable ones, no option. For the little ones, the portable ones, you have to switch the neutral, no option. For the mounted ones, permanently mounted ones, you have the option. Generator to be located. You have to have a disconnect next to the generator, guys. The mounted generator is right next to the generator within sight of the building, so you can disconnect the power. If it's portable equipment, talked about the portable generators. The portable generators, they allow you to ground them through the plug, which is really interesting. I don't want to open this can of worms, Zach. But the frame of the portable generator is actually bonded and grounded through the equipment grounding conductor that comes in the cord and the plug, which is not, we don't do that often. But this is only for the portable ones, the one that you haul up to 15 kW. So, all right, generator runs standby. When we size generator, and I don't want to open this can of worms, guys, but I'm going to remind you one other thing. When we size generators, the conductor here is we take 1.15 times full load current of the generator. The conductor. If this is my gen, here's my gen. I'm not going to open this can of worms for one reason, because I open it next quarter. We size the generator conductors by 115. Why 115, 120, not 125? Because the code, Article 445, says 115. When you add your loads, they are recommending having a 20% increase on the load for future expansion. This is opinion. You can add 25, 20, 10, the same size. It's a good idea to add them though. Okay, address standby system. Generators require a considerable amount of work. If check for the sound. Okay, a couple of things, guys. Generators that we don't even think about it. Number one, you might need a permit from the city that you have if you have a permanently installed generator. And sound ordinance. They have a sound ordinance is a big deal. Probably, Chris, you encounter that one. Especially when we have bigger generator, diesel generator driven, they have measurement. The inspector will go measure at the property line, and you have to have, and I'm not going to go with the numbers now, a certain amount of decibels so you don't annoy the neighbors, especially in residential neighborhood. So if you're installing one, Ashley, at your farm, probably don't care much. But if you're installing in the city where my neighbor is right next to me, I might have to check with the city what do you do, by the way, if it's too loud? What do you do? You have to buy an attenuating enclosure. They have it. But it makes your equipment what? Jack the price of the equipment higher. So it's not like you can't have one. If it's a sound or noise ordinance in your city, then you have to buy an attenuating enclosure that mitigate is the word mitigate the noise, and so your neighbors are not annoyed in the middle of the night when your generator is up and running. Hopefully so. Okay. Any question, guys? Any question about this? I wanted to introduce this one, guys, because that will be an opening for a big topic as we move into the emergency legally required and generators and separate drive system grounding. And I didn't say anything about grounding and bonding yet. That's coming later on the commercial industrial. Questions? I finished even 10 minutes ahead of my time, man. Okay, thank you.